Let's start with the IO-bound tasks. They are operations limited by the speed of input and output devices, such as disks, networks, and other peripherals. These tasks involve waiting for data transfer, so their performance depends on how fast the I/O device can handle that transfer. Some examples of I/O-bound tasks include reading or writing data to a database, reading data from a file, or sending data over the network. All of these are tasks normally performed by a network server, such as Node.js server. On the other hand, CPU-bound tasks are operations limited by the processing power of the CPU. These tasks don't involve waiting for data transfer from external devices, but are instead constrained by how much data the CPU can process at a time. Examples of CPU-bound tasks include mathematical calculations, image processing, encryption, and compression. When it comes to CPU-bound tasks like computations and data processing, Node.js, though single-threaded by default, isn't entirely powerless. It delegates these tasks to the thread pool provided by libuv, a key component of Node's architecture. libuv can spawn multiple threads up to a default limit of 4 to handle these tasks concurrently. However, this thread pool size, of course, has its limits. If the number of CPU-bound tasks exceeds the available threads, some tasks will be queued until a thread is free, which can lead to performance bottlenecks. Despite this mechanism, Node may not compete as effectively in scenarios where milliseconds count, compared to languages inherently designed for multi-threading, such as C++.